traffic simulation. In this presentation, I'm going to give an introduction about it, and then I will cover some of the software programs which we use to simulate traffic. I will touch upon the algorithms being used by those programs. I will also mention about what kind of inputs we need to provide to run traffic simulation and what kind of outputs we will get from it. Finally, I will mention about the scope of traffic simulation. I will tell where we can readily use traffic simulation and where we should be careful in using it. What is traffic simulation? Traffic simulation is modeling the movement of vehicles on any given road network. We try to mimic traffic environment virtually. See, using a CAD program, we can model a house or a structure and we evaluate its performance in terms of functionality, appearance, aesthetics, and so on. In the same way, we can use a simulation program and build a road network there, and we input where the traffic should go, from where to where, how many vehicles should go. Then when you run the simulation, it will look like a video game, but it's not a video game. Video game's purpose is entertainment. A traffic simulation will help you with many outputs like travel time, stop time, all those outputs. With that, we can compare what if scenarios. For instance, what if I close a lane for maintenance? What if I change the signal timing? What if I build a flyover instead of a big traffic junction there? So we simulate the traffic there and then we take the outputs and we analyze which one is the best scenario. So in short, traffic simulation helps us to evaluate different scenarios, different control strategies. That's the purpose of traffic simulation. Now, what are the various commercially available simulation programs? These are some of the famous and popular programs: Pyramids, Visim, Aimson, Cube, Transims, and Commute. In late 90s, they started with something called NetSim in the US, Network Simulator. Then came Freeway Simulator, mostly at the same time. Then they changed to Corridor Simulation. They were simple, they were two-dimensional, 2D graphics. The very first time, simulation was given a graphical interface. Until then, we just used formula and we calculated the positions. So we never had a chance to visualize what's happening in the program. It was like a black box. We were able to see how long is the queue length, how vehicles are changing their lanes. That was a big step then. Later came Pyramids, Visim, all 3D programs. That gave us even better picture of what's going on in the traffic world. Because now with the 3D program, we can model grades in the highway, ups and downs. So what happens if the slope is this much? What happens if the slope is not sufficient for sight distance? That facility helped us to understand traffic behavior even better. Around 20 plus years ago, I did my PhD in the National University of Singapore. At that time, I used first NetSim to model bus operations. After that, I switched over to Pyramids because Pyramids provided application programming interface where we can write our own programs, small routines, and then we can run it with the main program. That is how these simulation models are evolving. Now, I'll talk about the algorithms used in traffic simulation programs in general, and I will also give a brief intro about what do we input and what we get as output. The programs we just saw are of microscopic modeling nature, which means individual vehicles are modeled. Their positions are determined every time step of the simulation. When we say that every vehicle's position is updated by the simulation program, what it does is it always look in front of every vehicle. So where is the vehicle in front? So I follow that vehicle. I should not hit that vehicle, collide with that vehicle. So the safe distance is maintained. If I want to change lane for this vehicle, we use lane changing algorithm to find the gap and move the vehicle from one lane to other lane. Sometimes we use gap acceptance model at junctions. We also use weaving, merging kind of movements in rotaries or roundabouts. We have to validate our program. That is where these things come. So we might be fine-tuning certain factors there, certain parameters there, so that the output should reflect what you measure in the field. Something like speed of the vehicle or traffic queue length. So that is where we need some knowledge about these algorithms. Now we'll go for input and output. What we input? We build the network, road network. There is nothing there in the program. When you open it, it will give you the facility where you can create a network using something called nodes and links. Nodes are something like junctions and links are the space, the road in between them. Alright. So in that network, we specify where are the origin points of vehicles and where they will actually go. These are all the inputs. For example, if we want to model a junction having 4 approaches, in the field, we take some measurements there. How many vehicles are going straight from an approach? How many are turning left? How many are turning right? All these measurements we make in the field and we put them as input here. Then we run the simulation. We also specify control algorithms where do we have a stop sign there? Do we have a yield sign there? Or do we have a full-fledged signal system there? What about the green time? What about the red time? Every data from the field we input here and the simulation program runs it and gives you outputs. How long is the queue? How much is the time spent from one place to other place? We will also verify this data with the field data collected. That's validation. So once the validation process is over, you can make changes here. Say, for example, closing a lane or moving the bus stop from another 100 meters from the original position. These things we cannot do in the field just like that. That's exactly where simulation comes very handy. So depending upon what we really want, we define these scenarios. Is our aim to reduce the traffic congestion there? What we can do about that? Every idea we have in our mind, we can try to define a scenario there and get the output. So this is how we deal with inputs and outputs. We will now see the scope of traffic simulation programs, where we can use them and in what situations we should be a little careful. We have 2 different conditions of traffic: homogeneous and heterogeneous. On the left, cars forming queues on defined lanes. On the right, we see a chaotic situation there. There are many types of vehicles. There is no control there. It's an uncontrolled intersection. There are some encroachment in the footpath area also. This is the situation we see in developing countries. Many cities of developing countries have this problem. When traffic simulation programs were developed in the Western world, the focus was the homogeneous traffic. It's a queue system. One car follows the other. So it was easier to model such situations. So where can we apply those simulation programs we just saw? They are very well suited for homogeneous traffic conditions. There is no doubt about that. Can we use them for modeling heterogeneous traffic? Even to input such condition will be impossible. So we need to do some approximations there. So that is dependent on what we really want to achieve by modeling the junction. If we assume that there are some lanes there, the same flow happens in a lane system there, and if I want to put one more lane, that will imply increasing the width of the road. So we have to come up with some approximations. Visim, they have some features on modeling heterogeneous traffic, but not to the level of modeling what is shown on the right side in the screen. We should be careful about where to use these simulation programs and where not to. Thank you very much for watching this presentation.